Well, friends, greetings from Total Output Power Solutions. In the past, some engineers they were asking for savings due to improvement in ash unburns in a PF boiler, pulverized fuel boiler. Well, I am Manohar Tatvadi from Total Output Power Solutions. We will discuss some points about the uh, improvements or savings due to improvement in unburns, ash unburns. Now, here the The ash is the product of combustion of pulverized fuel, that is coal, inside the pulverized fuel furnace. So when coal is burned totally, the ash will be formed. But somehow, though the coal is pulverized in the coal mills and then burnt in the combustion chamber of boiler, it does not burn fully, and you get unburns in the bottom ash and as well as in fly ash. Now, even a small fraction of about 0.4% in unburns will save almost a lakh of rupees per day, and hence we must try to reduce the unburns as low as possible. Now, here you see the diagram, losses and efficiency as per designer. The designer says that he has designed the boiler, pulverized fuel boiler, with the input heat, total input heat is 100%, and then the heat supplied to the turbine output is with turbine output is around 86.5%. He has given the losses also as per the designer. Heat loss due to hot flue gases going out, that is 6%. Then heat lost in unburnt fly ash and bottom ash 0.4%. Excess air loss 0.75%. And then other losses, they are also depending on the coal quality. But he has given the coal quality also, designed coal quality also. Whereas in actual measurement, when we actually measure the losses in the boiler, you will see that the flue gas heat lost in hot flue gases is around 6.5%. The excess air loss is 1%. The heat lost in unburnt in fly ash and bottom ash is 4%. And of course, because of the coal quality, the other losses are there. Radiation loss is also constant 0.2. So with these losses, the turbine efficiency comes out to be 81.1%. This is the actual measured efficiency. The test data for a 210 megawatt unit, the coal input per day was 3000 tons per day. The moisture content, coal quality was moisture content was 7.9%. Inherent moisture was 3.26%. Ash was 49.7%. Volatile matter is 22.5%, and fixed carbon comes out to be around 24.5%, totaling to 100. Then the unburnt in ash was the test samples were taken, and there we found that it was 4%, and the flue gas APH outlet temperature was 150 degrees centigrade. So with this we calculated the efficiency by loss method, and you can see the various losses. Loss due to hot flue gas came out to be 6.5%, loss due to moisture 2.4%, loss due to hydrogen 5%. Now loss due to unburns, this is 4%. Loss due to excess air is 1%, and the total losses came out to be 18.9%, and the efficiency we calculated with loss method was 81.1%. Here you see the loss due to unburns is around 4%. Now how we will see how the unburns in ash uh, affect the actually the quantity of fuel. The daily ash generated will be equal to the percentage of ash in coal multiplied by the quantity of coal consumed tons per day. So the percentage of ash was 0.497%, and the quantity of coal is 3000. So you get 1491 tons per day. This was the ash that was generated per day. The quantity of unburnt carbon in ash. Now the unburnt carbon was 4%. So the unburnt carbon in ash multiplied by the daily ash generated. So 0.04 into 1491, this is 59.64 tons per day. this much amount of unburnt carbon was there in the ash. Now this is purely carbon. It is devoid of the volatile matter, and it's only carbon having a very high calorific value. So we calculate the equivalent coal with this. The coal quality we have is the fixed carbon in coal is 24.5%. So unburnt carbon in coal multiplied by 100 divided by the fixed carbon in coal. So it comes out to be around 243.42 tons per day of coal that you are using. This carbon, this much unburnt carbon is equivalent to around 243.42 tons per day. So if the cost of the coal is around 4,000 rupees per ton, then the loss per day would have been equal to 9,73,680 rupees per day. So this is the when the ash is 4%. Now we decrease the ash percentage from 4% to 3.4%. We tune in the boiler. We take some other this thing. No, we tune in the pulverized mill also. Everything is tuned, and then we get the ash unburnt in carbon ash reduced to 3.4%. So again the same calculations. The daily ash generated is the same because you are burning the same amount of fuel. The quantity of unburnt carbon in ash would be now 50.694 tons per day of carbon. The equivalent coal for this would be come out to be around 206.91 tons per day, this much amount of coal. So the reduction in coal, that would be around 36.12 tons per day. This was the reduction in coal. Now it may not, because you are burning 3000 tons of coal, so there may not be any reduction in coal, but it will increase the output of the boiler. Maybe you have got increased this thing kilowatt hours, so that is there. So if the cost of coal is rupees 4,000 per ton, then the saving per day would be around 1,44,480 rupees per day. So this was about the unburnt in ash reduction to 3.4%. If we still reduce it further to further to 3%, then the daily ash generated, the same calculations we carry out, and from there you will see now the quantity of unburnt ash that is reduced. So the carbon that was in the ash was 44.73 tons per day. That much carbon was there, and that if you make it equivalent to coal, that will be around 182.571 tons per day, this much amount of coal. So the reduction in coal would be around 60.46 tons per day. So if the cost of coal is 4,000, then the same calculations here, and you see that you are saving around 2,41,840 rupees per day. Now, what are the reasons behind this unburnt carbon in ash? What are the reasons? So unburnt carbon in bottom ash, you must check the fineness of the pulverized coal. There may be some milling problem, and due to which the fineness of the coal is less, and that is why you are getting more unburnt in bottom ash. So you must check the 84% should pass through 200 mesh. That is the fineness that we generally maintain. Then check the primary airflow. It may be less than the actual flow. It may be less than the desired flow, or it may be unequal at or the four corners. There are four corners A, B, C, D. So check the primary airflow. Maybe you may have to replace the uh, orifices in the coal mill to equalize the flow at the four corners. This may also amount to unburnt carbon in bottom ash. Now check the mill classifiers. The mill classifiers may not be, means they may not have been adjusted, so they are delivering the they are not delivering the actual fineness. So you can check the mill classifiers. Then check the grindability index of the coal. Maybe the coal is such that the grindability index, the coal quality is such that it is not being grind to a fine powder or 84 whatever we require, 84% to 200 mesh or that. So you can check that grindability index also. Then coal pipe leakages. One more point that I wanted to bring to your notice: if the coal pipe leakages are nearer to the coal burners, then you will find that some fine particles, they are going outside through the leakages, and only the particles which are heavier, they may pass through the pipe and may go inside the combustion chamber, and because of this, there will be unburnt in bottom ash. The coal burner diffusers, if the diffusers are worn out, then also the coal will not be spread equally or evenly in the combustion chamber, so it may not burn properly. So there may be unburns due to this also. So you will have to check all these points for the bottom ash, unburns, more unburns in bottom ash. The now unburnt carbon in ash in fly ash. This is actually more important, because the now you have grinded the coal to a fine powder, and then the coal is not burning. Then the excess air may be less than the required. So check the oxygen percentage. Maybe if you are getting the oxygen percentage correct, still there may be some leakages in the furnace zone. So you must check for the leakages also, air leakages. Then the PA pressure is more than the required. Some 800 millimeters of water column, this may be the PA pressure, or maybe somewhat whatever is the design pressure that you should maintain. If it is more than that, then it may carry the particles beyond the furnace combustion zone. So it might have increased the velocity of the mixture of fuel and air, and the mixture on the coal is not burning fully. The burnal tilts are not functioning correctly at all corners. Some corners, it may be the burnal tilt may be on the upper side, and in some corners the burnal tilt may be at the lower side. So this may be a problem. So burnal tilts, they must also be checked for proper functioning. Then proper adjustment of secondary air dampers. Secondary air dampers are maintained for the complete combustion. So if they are not open, means they are not open, or sometimes they are showing open, but from the inside they might not be open. So the proper adjustment of secondary air dampers is also necessary for the reduction in unburnt carbon in fly ash. The coal burners diffusers, they might have been defective somewhere, they might have even fallen. So because of this, the top side coal burners, they are directly diffusing all the coal into the not in the combustion chamber but on the top, and then it is going out, and you are getting unburnt carbon in fly ash. Then there may be some problems regarding the soot blowers. Soot blowers, puppet valve, they also should be checked. If the puppet valves are defective, means maybe it is passing, and the blower is continuously blowing the steam inside, the coal may not burn there, and it will pass over the second pass even, and then you may get some carbon in fly ash, unburnt carbon in fly ash. The last and the most important is air ingress in boiler. So all the air ingress is amounted to the incomplete combustion of coal. So that must be checked, air ingress in boiler, that must be thoroughly checked. So these are the reasons for the more unburnt carbon in ash. There are some other reasons also. There may be some other reasons also that you have to check. So thanks for watching. Hope you have enjoyed the session. Please like, share and subscribe. Your comments are always welcome, and please put in your comments. I am Manohar Tatwadi taking your leave. My mail, you can mail me also the comments. The mail ID is given, mtatwadi@gmail.com, from Total Output Power Solutions, Balewadi, Pune. Thank you.